Hello students, this is Mr. Wilsey, and in this video I'm going to show you how to set up an apparatus for determining whether or not energy is conserved in a pendulum. Now, theoretically, when we pull back on a pendulum bob, we are giving that pendulum some potential energy. When we let go of the bob will swing, and some of that potential energy is converted into kinetic energy. Now, a pendulum, as we all know, swings back and forth, back and forth, back and forth. And this represents a great example of potential energy being converted into kinetic energy, and then kinetic energy being converted back into potential energy, and then the cycle repeats itself on and on again. Now, when we say that energy in a pendulum is conserved, we mean that no energy is lost. However, we live in the real world, and we will actually be able to see that energy is not completely conserved in a pendulum, but it's very, very close. So you're going to need a couple of different things for this lab. First of all, you're going to need a meter stick. So I've got my meter stick in the picture here. You are going to need a physics stand. The physics stand is this purple thing here. You are going to need a pendulum angle measurer. Can't really think of a better way to say that. The pendulum angle measure is this device up here. Then you will also need a pendulum set. It should come in a little baggie. The baggie will contain a wooden bob with some washers and yellow string. And then finally you will need a black timer kit. You should be used to using those by now. Now inside the black timer kit, you will only need 4 pieces. You will need the power cable. So I've got my black power cable here. You'll need 1 photo gate, even though the kits come with 2. You'll need 1 phone cable, like I have my blue phone cable here. Again, you'll only need 1, and then you'll need your timer. Now I want you to set up the pendulum apparatus like you see in this picture here. Now you're going to need 2 more things. You're also going to need 2 blue knobs. The knobs screw into both the pendulum angle measure and also into the side of the photo gate. Make sure to use this bubble level to make sure that your pendulum apparatus is level. You might need to adjust either your table or maybe stick some sheets of paper beneath one of the 3 corners of the stand. Now, before you hook up the pendulum, you need to measure the mass of the pendulum bob, washers, and string in grams using a scale, and then convert that into kilograms. And then I want you to also measure the width of the pendulum bob. You'll probably measure that in centimeters, convert it into meters, and then you can put the pendulum string into the wooden dowel with the slot in it. It doesn't matter how long the pendulum string is, but what does matter is that the widest part of the pendulum bob has to fit in between the photo gate. But more specifically, you'll see a little rectangular hole in both sides of the photo gate. On one side is a sensor, the other side is an emitter of an infrared beam. And that infrared beam needs to go across the pendulum bob at its widest point. So make sure that your pendulum string is just long enough for that to happen. Now, on this sheet of paper, or this PDF that Mr. Wilsey gave you, I want you to measure the height of the bob above the table at the lowest point in its swing. On the left here, I have my meter stick that is flush against the tabletop, and my pendulum bob is hanging straight down. You can see that when the pendulum bob is hanging straight down, it's about 21 centimeters above the tabletop. 21 centimeters is what goes right here. Now, I want you to conduct 5 trials of this experiment at different angles. So you're going to pull the pendulum bob back a certain distance, and then you're going to measure the angle that the pendulum string makes, as well as the height of the pendulum bob above the tabletop. Look at how I'm measuring the height of the pendulum bob. In this photo, it looks like about 29 centimeters. That's how high the pendulum bob is above the tabletop. So 29 centimeters is what I would type right here. Sorry, 29. And so the difference in height between the highest and lowest point is 8 centimeters. Actually, it's asking me to type everything in meters, so I actually need to write 0.08 meters and 0.29 meters. That's the height. And then over here, I would type 0.21 meters. Okay? So this is filled out correctly so far. Now, in order to measure the speed of the pendulum at the lowest point in its swing, we will need to use the photogate timer. And the photogate timer should be on these two settings. It should say interval. Interval should be lit up down here. And then whichever slot, either A or B, that you plugged the phone cable into, that should be lit up as well. Now remember that this number here tells you how many seconds it took for the pendulum bob to pass through the beam. That number will go right here. That number will allow you to find the speed of the pendulum as it passes through the photogate. You will need to use the width of the pendulum bob in meters, which you should have already measured, in order to calculate the speed. Now, remember, the whole point of this lab is to see whether or not the potential energy of the bob at its highest point is in fact equal to the kinetic energy of the bob at its lowest point. Now, if you watched Mr. Anderson's videos for homework, like I asked you to, you will know how to calculate the kinetic energy of an object, and you will also know how to calculate the gravitational potential energy of an object. And that is the potential energy that gives the bob its motion. Well, I hope that this video was helpful to you. Now, if you haven't already, get started assembling your pendulum apparatus.